Thanks for joining us for the interview portion of the Data Speaks competition created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a Science Communications with Sequent, and I'm joined today by Marius from Helmholtz Institute Freiburg.
Yeah, hi.
Welcome.
Thanks for having me.
Of course. So your original abstract title was Simulating Sensor-Based Pre-Sorting with Automated Mineralogy Data. So what is your revised non-specialist abstract title?
My revised title is Sorting Rocks Using Big Data Promotes Sustainability and Saves Energy. It basically says the very same thing, just with words that are a bit easier to understand. And we have big data as a catchword in there because everyone knows about big data and how important it is and what the capabilities are, but that the potential is yet to be explored.
Yeah, great. And so what question are you trying to answer?
So the point is, in minerals beneficiation, we're trying to remove particles from the concentrate stream, particles that are of little or no value. Now, best is to do this when the particles are still coarse, because the coarse particles, once you have removed them, you don't have to grind them anymore. And the method typically used for that is called sensor-based pre-sorting. Therefore, the particles are presented on a conveyor belt. They're being detected by a sensor, and then the data is being processed and a decision is being made whether the particle should go to concentrate or to tailing. Now, the question is, which property of the rock has to be detected by the sensor? And that's the question I'm trying to answer.
Great. Okay, and so what concept does someone need to know then to understand your research?
So the point is, when people try to find out what sensor they can use for their ore, they're typically just doing preliminary analysis and trying to find out what sensor could work. And then they are running trial and error batch tests. So every ore is a bit different, and eventually you might have found a sensor which somehow worked for your ore, and you could implement that now in your beneficiation process. But the point is, you don't really know a lot. You don't know why did that sensor work. You don't know if there would still be a possibility to optimize the work of that sensor. And it could be even possible that you could use a completely different sensor which you haven't thought about before. And that's why we decided to have a simulation-based approach where we take data before doing the batch tests.
Awesome. Okay, and so what role does data play in your research then?
Well, data plays obviously a major role. So we have, for a case study, analyzed more than 100 thin sections with more than 5 million analysis per thin section.
Wow.
And this data makes it possible for us to have just a very detailed understanding of each sample, and we can have properties like the mineral content of the sample, the density, the mineral associations, and we can use all this information to simulate what would be the outcome of a sorting routine. Now, all the simulations we could have, some of the simulations we did were really surprising. The results were really surprising. So we detected properties, or we found out that properties can be used for sorting, which we had absolutely not thought about before. The second step was then to reproduce our sorting experiments with commercially available sensors to just prove that our simulations are sound and trustworthy.
Great. And so why was it important for you to come here today and to share your data and your research?
So most people don't know about the energy consumption during a mining operation. But the point is that grinding particles usually costs between 60 to 85% of the energy of the whole operation. So if we can make it possible for many more ore deposits to implement sensor-based sorting, then all of them they can save more energy on the downstream. And that's why I think that there is a huge potential now with having big data available, because now we're actually capable of understanding the ore much better and of really finding the most optimal sensor for ore sorting. Also, in the future, it's probably going to be possible and easier to have sensors that are more precise, they are more accurate, and they are cheaper and faster. So I really believe that there is a big future for sensor-based sorting in this industry.
Yeah, it sounds like it.
Yeah.
Well, thanks for joining us today, Marius.
Thank you very much.
Yeah, of course. So once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch all the videos on YouTube or Twitter, #CDataSpeak. Thanks.
Thanks.